We're on to question 5.4, 5.4.1. Let's have a look. Given the identity is cos, and then open bracket x plus y, close bracket, times cos, and then open bracket x minus y, close bracket, and then it equals 1 minus sin squared x minus sin squared y. And then what it's asking us to do is to prove the identity, to prove that the left-hand side is equal to the right-hand side. The first thing that we can see is that we've got a compounded angle identity here, in that cos x plus y times by cos x minus y can be broken up into cos x times by cos y minus its opposite sign sin x times by sin y. So quite often what happens is I see learners want to multiply cos times x and cos times y. So just be careful of that. This is an identity, so we have to follow the rules. The other thing I want to mention is the plus now becomes a minus, and we can group this into 1, and then we have to multiply this by the same. We're going to apply the same identity here, cos x times cos y, and instead of minus, we're going to change it to plus sin x times sin y. It's at this point where you can carry on with your, simplifying. But what I like to do is I like to make things simpler. You don't have to do this, but maybe haven't thought of this. So what I'm going to say is let cos x equal to a. Let cos y equal to b. Let sin x equal to c. And sin y equal to d. And what you get now is very much a simplified version of what's going on above. So you get AB minus CD times by AB plus CD. Now to me that's a whole lot easier to work with. And what we get is AB times AB, that's AB squared, plus AB times CD. Then you get minus AB times CD, and then you get minus CD squared. So these two cancel out and you're left with AB squared minus CD squared. So let's substitute everything back to the way it should be. So this will be cos squared x times that by cos squared y minus, you get sin squared x times by sin squared y. Okay, the next identity we can see is because we want to get sin up top over there, what we're going to do is we're going to convert the cos into sin. So we go 1 minus sin squared x times by 1 minus sin y squared. And then minus sin squared x times by sin squared y. It's at this point where you can actually substitute again, but I'm not going to do that. Let's just multiply this out. You get 1 minus sin squared y minus sin squared x plus sin squared x. Multiply that by sin squared y minus sin squared x times by sin squared y. So let's have a look. Is there another one? No, there's not another one. Is there sin squared y? No. Is there sin squared x? No. But then what you'll see is that these two are exactly the same, except one is a plus and one is a minus. Therefore, they cancel out. And if you look over here, that is exactly what they want in your answer. 1 minus sin squared y minus sin squared x. We're on to 5.4.2, and it says, hence determine the value of 1 minus sin squared 45 minus sin squared 15 without the use of a calculator. The word hence means that we can actually use the previous question's answer. What we know is that 1 minus sin squared 45 degrees minus sin squared 15 degrees is equal to cos x plus y times that by cos x minus y. Now the nice thing about this is that we don't have to do the whole working out that we did in 5.4.1. We can just jump straight to it. And what do I mean by that? That means if we take cos x plus y times that by cos x minus y, we can just simply now apply the compounded angle identity, which is cos, what is x? X is 45. What is y? It's 15. And then we can go cos, what is x? X is 45 minus 15. And these are degrees, obviously. So this will be cos 60 degrees times that by cos 30 degrees. Now all we need to do is take our triangle. So what is cos of 60? It is adjacent over hypotenuse, which is a half. What is cos of 30? It's also adjacent over hypotenuse, but in this case, it is square root 3 over 2. Now we can't use our calculators, just remember that. So we multiply the 2 by 2, it's 4, and then the 1 by square root 3. And there's your answer. Thank you for watching the video. If you have any questions, please drop your question in the questions below. We'll read and respond as soon as possible. If you need more help with math, please click the link below that goes to my channel and go view what we have available there.